My name is Sheherbano. My roll number is 16TE04. Today our topic is Introduction to Digital Filters. Digital filters are used for two purposes: signal separation and signal restoration. Signal separation, when signal separation is used to separate two signals or to remove noise and interference from signal. And second is signal restoration. When signal is distorted and we want to get original signal, we apply signal restoration. We apply filters. And what are kinds of filters? There are two kinds of filters: analog filters and digital filter. Analog filters are cheap, fast, have large dynamic in amplitude and frequency, while in digital filter, it is not cheap but superior in level of performance. Kind of responses of filters. Every filter has three kind of responses: impulse, step, and frequency. Impulse response and step response. First discuss impulse response. If input is impulse, then output is also impulse and called the impulse response. And step response, if step signal is given as input, then the output is also step. How digital filters are implemented? Digital filters are implemented convolving an input signal with digital filter impulse response. Impulse response generates step response after discrete integration, and impulse response generate frequency response on linear scale by applying fast Fourier transform. What is decibel? Decibel is the way of expressing ratio between two signals, and we can represent as dB is equal to 10 log base 10, ratio of 2 power and ratio of 2 amplitudes. Next is time. How information is represented in signals. Information is represented in time domain and frequency domain. In time domain, there is amplitude versus time, while in frequency domain there is amplitude versus frequency. In step response shows how information represented in time domain changed by the system, and in frequency response shows how information represented in frequency domain is changed. While a good performance in time domain result in poor performance in frequency domain. Parameters in time domain. There are three parameters: step response. Line by line we study all this. First is step response. If the step response is slow, then we consider it poor, while if step response is fast, this is a good example of filter. Next, overshoot. If there is a overshoot, then we consider it a poor filter, while if there is no overshoot linearity, we consider it a good filter. While for phase, if linearity is considered to be good, if there is no non-linearity result in poor performance. Then we can read about frequency domain responses. Here are all poor responses and here are good responses. First is roll off. If the roll off is slow, then we consider it is poor, and if the roll off is fast, we consider it good. Pass band. If there are ripples in passband in filter output, then we consider it poor, and if it is flat, we consider it good. Stop band attenuation. Here we see attenuation being stopping. Here it stops too early, then that we consider a good filter. Kinds of filter. There are four kinds of filter: low pass, band pass, high pass, and band rejector. First is low pass. Low pass filter allows low frequency to pass and suppresses the high frequency, while in band pass allows certain frequency to pass while stop other frequencies. This is stop frequencies, stop band, and this is pass band, while this is transition band, changing. While Next is high pass. High pass allows low frequencies to stop and passes high frequencies, while band rejector rejects certain frequencies. This is pass band. Uh, this is transition, and this is rejector. High pass filter. Formation of high pass filter. How can we form high pass filter? By two methods. What are these methods? Spectral inversion and spectral diversion. Uh, if we subtract h of n from s of n, we get high pass filter. How? If s of n is an impulse train, then we subtract low pass response, then we get the high pass. And the second method is spectral diversion. Original low pass filter is passed and then frequency is reversed, then high pass filter is obtained. Next, band pass filter. How can I form band pass filter? There are two responses. This is low pass and this is high pass. When we combine low pass and high pass filter, we get a band pass filter. Like this is low pass, high pass, and the result is band pass. Band rejector filter, if there are two filters like low pass and band pass, and we add them, then we get the band reject filter.